Hello, thanks for joining. I am Mike Bauer, and along with my colleague Dan Kelosky, we will be presenting on Mainframe DevOps and Modernization. Before I get started, a little bit about myself. I started as a software engineer at CA Technologies, now Broadcom, working on mainframe applications a little over 6 years ago. And when I first started, I went through a training program to learn the tools of the trade. And Dan will talk a little bit more about that developer experience later on. But then a few years ago, I transitioned into a product owner role for what is now the Zowe CLI. And the Zowe CLI, as we'll talk about, is a technology that enables you to make use of modern distributed development technologies while working on the mainframe. When I'm not working on the mainframe, you can likely catch me out hiking with my wife and dog Mira, or at the local racetrack. We got an action-packed agenda for you today. We'll kick it off with what is a mainframe and why it is important. Then I'll send it over to Dan for a demo of today's developer experience on the mainframe. And then we'll come back with what is Zowe, why it is important, and how it can modernize the mainframe development experience. And then Dan will show us that with a demo. So to start off, what is a mainframe? Well, mainframes are high-performance computers that are capable of handling many transactions. Their key benefits are scalability and security. They're also very stable. They typically ensure backwards compatibility, so there aren't that many changes. And it's important, as we'll talk about in the following slide, that these mainframes are stable and that they power much of the world's economy. The importance of mainframe. I posted some interesting facts, but the ones I'm most interested in are mainframes handle 90% of all credit card transactions. And as of 2019, 96 of the world's largest 100 banks, 9 out of 10 of the largest insurance companies, and 23 of the 25 largest retailers in the US rely on mainframes. Mainframes handle 30 billion business transactions each day, showcasing that they are truly the backbone of the world's economy. As far as development on mainframes, I'm going to turn it over to Dan to give you a demonstration of what that experience looks like today.
Mike showed us what mainframe is and why it's important. And now we're going to look at the developer experience for somebody that wants to build software on the mainframe platform. My name is Dan Kelosky. I started in mainframe software development in 2009. I have worked for another software company building out software for non-mainframe platforms. But other than that 1 year, this is mostly what I've been doing. And so I'm going to walk through an example of what it's like to build software for the mainframe platform in a traditional development environment. In some of the CDCon material, they talk about how this is a virtual event with an aim to improve the world's capacity to deliver software with security and speed. So I want to set the stage here with how slow software development can be on mainframe. And what I have here is a screen print of some C code, C language code, being edited in a mainframe environment. It's a very simple C program, basically a hello world. And what we're going to look at right after this is what it looks like to create this program in the mainframe environment, build it and run it, and view the output. Of course, the steps I'm going to go through are kind of generic in practice. Real production environment for mainframe software vendor or some other site that builds mainframe applications. The process would vary with the different tools that are available to them, the language they're developing in, also lots of controls around internal process and security. But you'll get an idea of what it looks like to build and run software on mainframe. ZOS is an operating system for the IBM mainframe. There are others, but ZOS is what most are familiar with. Of course, that's for people that are familiar with mainframe in the first place. To get started, Using ZOS, the user typically logs on to TSO. TSO stands for Time Sharing Option, and I'm in TSO by this ready prompt here that's on my screen. And TSO is just a user interactive session with ZOS. From here, you typically launch a panel application called ISPF. ISPF is a basic way to view and list your files, how you edit your files, and it's also an entry point to get into other applications like vendor applications to view more information about the system. If I want to build some code, I need to navigate to my datasets. I did that with a command 3.4 to get to my dataset list. Datasets are files on ZOS. We'll leave it at that. If I want to create a program, I need to create a file in one of my datasets. There's a lot of history here, a lot more we can talk about, but for historical reasons, member names contained within a dataset are restricted to 8 characters. So if I want to make a Hello World program, I need to select the name for my Hello World program that's 8 characters or less. So I'll truncate this. I'll call my program Hello World. Don't read into that. I love coding on Mainframe. I'm not trying to say this is Hello World. This is how I create a C program on Mainframe. Real quick, I want to go back to the slides before we show what it's like to build out this Hello World C program in an ISPF editor. Looking at this program in its entirety, I said it's a Hello World C program, but there's some other things going on here. If you know the C language, it might help, but it's not required here. Typically in a Hello World C program, you have your main function, and in the body would be a function called to printf and Hello World. And printf, if I coded that function here, would write Hello World to standard out, and that would be all that's needed for Hello World C. Again, I have some other things going on here. I happen to have an S printf, which is somewhat similar. It has some of the capabilities of printf, but doesn't write to standard out. And then I have this line at the bottom, return 7. The number 7 is completely arbitrary here, but I'm using that to illustrate a point, which I hope to make on this next slide. So that Hello World C program is actually a Hello World Metal C program. Metal is a keyword on the IBM C compiler that says, I don't want this code to be dependent on any runtime. So Metal meaning not dependent on any runtime, running close to the hardware on the bare metal. And since it's running close to the hardware, bare metal, when I code some Metal C and I compile it, what's actually generated for me or output for me is assembler statements. So this is IBM mainframe assembler statements following this return statement. I coded a return 7. There happens to be a 7 on this next instruction, which is loading the number 7 into a register, 15, and then some other stuff that's going on. I tried to frame this presentation or example of traditional mainframe development in what I actually do, which is write back-end system-level code for the IBM mainframe. So that's Metal C code interfacing with assembler, but I'm going to stick to C. The mainframe supports writing code in more modern languages, like Java, Go, Swift, Python, stuff in Node.js on the platform, but I'm doing this in the context of Metal C. So I want to show building a C program by hand. This might go just a little bit slow, but that's kind of the point. Remember, we want to talk about how we can deliver software with greater speed. And the way I want to do that is show how it's currently slow today. And that's a technology that makes this development experience a little bit faster and better. I'm using the ISPF editor, and I'm going to just try to code up this C program, ideally without making any mistakes, so you can see what it looks like to code in ISPF. So I hit enter here, and if I want to insert a new line, the way you do that is put an I on this first column to insert a new line. If I put a space and hit enter, I get another blank line. ISPF, I actually don't have a problem with this as a code editor. I think it's kind of powerful, especially for certain column-oriented languages like COBOL or assembler. But there are some other quirks that make this a not ideal environment for building out new software. Things like IntelliSense or navigating symbols, or just to be able to hover over a data type and see its value. I'm going to start with just a hello world program and a return zero here. Actually, I'll make this a 7 as was in the presentation. I won't code those other pieces for now, but this is a hello world program in ISPF that I coded to get to see what the interface looks like. Again, there's no IntelliSense. I can't click and navigate to this header file to see definitions in there. If I want to insert new lines again, this is how I do it. I can get some basic colorization, but beyond that, no help when writing in the C language in this editor. So I went ahead and built out the rest of this program offline so you didn't have to see me type it all out. What's been introduced here is the remaining of the code almost verbatim as you saw on the slides. This WTO _ buff piece is a structure defined in this WTO.h header file, as is this function WTO. So WTO stands for write to operator. It's a low-level assembler-based service, and so the code in this WTO.h is the assembler code that wraps and makes this callable from Metal C. As you recall, I don't have a full runtime available to me in this Metal C environment. I do have some runtime built-in functions, for example, the sprintf function. So I can take a message in a C format string and build that into a buffer. And I'm doing that with the sprintf function. So I take my hello world, I build it into a buffer, format it, and then I can call my own implementation of an I/O routine in this WTO to write my output to operators, so I can actually view the output somewhere, and then I do my return set. So I have the code for my hello world C example finished, but now I need to build it. And the way you do that on Mainframe typically is through what's called JCL. JCL stands for Job Control Language. So I'm going to create some JCL similar to how I created my C program in a COS dataset. So I create this hello world JCL. And the way most people create JCL, as far as I know, is they copy from JCL that does what they already need. It's very rare I see people create JCL from scratch. You have some JCL that somebody built a long time ago, and you copy it and tailor it to what you need. So this JCL was a template JCL to build and run a C program, a Metal C program. So it's called C template. And I'm going to change C template to my hello world. And what this JCL will do is then invoke the IBM C compiler to compile my C code into assembler statements. Next, I'll invoke the IBM assembler. JCL runs sequentially some number of programs. So the next thing that's wrapped up here is it's going to invoke the assembler to take my assembler code and emit object code. Then my object code will be linked or through the COS IBM linker or binder and create a final executable. And lastly, this JCL will run my program. One more thing before I can actually build and run my program is I need to describe how my program is linked together. And one more data set I need to create with some control statements. Again, I'm going to copy these from template. And if what I'm doing here is unclear or confusing, that is what I'm going for. So we have, on the outset, the premise of this was that we want to be able to deliver software faster. And in a traditional mainframe environment, if this is the interface and this is the tooling, You can become quite proficient at it. I'm comfortable in this environment, but there's a steep learning curve and a lot of subtleties to pick up when you're working in this environment. And so I'm trying to show this is the way we're doing some people do things today, and then we'll show a better way so that we can deliver software faster. So let me recap here. I have my C code, my metal C code. I have some JCL to build and run my C code. I have some statements about how my C code should be built together into a final executable. So the last thing I can do is submit my JCL. Again, JCL stands for Job Control Language. So JCL submits a job, a batch job that gets scheduled by this component called the job entry subsystem. So I need to wait for my JCL to be scheduled and run before I actually get my output. And I made a mistake while I was doing that. And this is a deeply manual process, very error prone. Another reason why it slows down, I think, software development in this traditional interface. There's a lot of data on the screen. Two things to catch. This tool I'm showing here is sysview, a way to view job output from a program you're in. It's a batch job. The C code is the condition code, and the output is 7 because my program had a return code 7. So I could see my program ran and the last number it returned was a 7. And the last piece here, if I select and I look at this job output, not trying to make sense of any data here, I could see hello world. So this is how I could code, build, and run a hello world metal C program on Mainframe. At the end of this, I think we'll have a live Q&A, so if you have any questions about this, please think about, frame that or ask those questions, and we could try to describe this more. And then shortly, we'll look at ways to make this development experience a lot better. All right, so having seen the example of what it looks like to build a C program and run it on Mainframe, the one thing that's missing, well, maybe several things are missing, modern tools. Modern version control software. There is version control on Mainframe, but you didn't see Git in the picture there. Also, if I want to use other IDEs or text editors, how do I do that? Or how do I integrate with CI/CD tooling, popular frameworks for test automation, pipelines, continuous integration, continuous deployment? How do I do that? And so we'll turn it over to Mike to talk about a platform to help solve that problem. And then I'll show up with one more demo to show a newer experience for editing a Mainframe LC program.
Thanks, Dan, for showing the development experience we typically see on Mainframe. Now I want to talk about how we are improving and modernizing that developer experience. So it's a little bit different than the training course I went through 6 years ago. So what is Zowe? Zowe is an open source and extensible platform for connecting applications and tools to ZOS. The aim is to make the ZOS mainframe an integrated and agile platform. And Zowe was initially released under the Linux Foundation Open Mainframe project in February of 2019, and it originated from contributions of Broadcom, IBM, and Rocket Software. A little bit about its architecture. What we have seen on the mainframe is an emergence of REST APIs. And as you have more and more REST services to connect to, you need a means to manage those. That means is the Zowe API mediation layer. From a user experience, the API mediation layer has a catalog from which you can view all available services on the mainframe, and it also allows easy monitoring of access to these services as everything is routed through a single port. And then there are some clients that are built on top of these services. We offer SDKs for various languages. Currently, our Node SDK is the most fully built out of the SDKs, Python close behind, and then we have Kotlin, Java, Swift, starting to be in development. On top of these SDKs, we also have integration with modern IDEs. We have extensions for Visual Studio Code, and we are just starting on an extension for IntelliJ. And then we also have a CLI, which is very useful for connecting other modern applications, modern development tooling with ZOS. And the CLI itself can be extended through plugins for various mainframe services. Here's a view of all of the different developer technologies that are enabled by Zowe. So starting from the top left, we see the Zowe command line interface. There's a variety of groups. You can look into each group for actions and objects on which to take those actions and build out your commands. Once you've mastered running the CLI interactively, as you can see in the middle, you can abstract that into scripts of your own. Maybe you use gulp task or npm scripts, or maybe just shell scripts or what have you. You can begin writing your own automation, and then ultimately including those in a Jenkins file, maybe running a Jenkins pipeline or other CI/CD tooling. We also have SDKs if you want to build applications or you want to script to the SDKs directly rather than invoking a command line interface, you can do so. In the bottom left, we see the Zowe Web Desktop hosts a suite of applications you can launch, including the API catalog, which shows you what services are available on the mainframe. And in the bottom right, we have the Zowe Explorer, which is a VS Code extension that allows you to easily interact with ZOS datasets, USS files, and jobs. Also, I mentioned that Zowe is a platform, so it doesn't just stop with what's available in the open source community, but vendors like Phoenix Software International, Broadcom, IBM, Rocket, Software Engineering have all built commercial extensions on top of this platform, which extends the number of services you can now access remotely. For example, now the CLI is up to 25 conformant extensions, allowing access to a wide variety of services and applications on ZOS. So now that you know what Zowe is, why is it so important? Prior to Zowe, it was very difficult to leverage distributed tooling because there wasn't a means to connect that tooling to ZOS, to the mainframe. And now with the help of the REST APIs, API mediation layer, and CLI SDKs, you have pretty much a standard way of interacting with ZOS from distributed tooling of your choice. You can use your IDE of choice, whether that's Visual Studio Code or IntelliJ. You can use your language of choice for scripting, whether it's Python or JavaScript or what have you. You can leverage your CI/CD tooling of choice, whether that may be Jenkins. You can use your source control that you want, such as GitHub, etc. So with this platform, it's really enabled the use of all of the different distributed technologies that are out there. And it also makes scripting on the mainframe a lot easier. So there are ways to script on platform, but there's not as many libraries available to share. So just for example, as many of you know, there are many packages on sites and registries like public NPM, for example, has 1.3 million software packages, or PyPy.org has over 250,000 packages that you can go out and leverage to help modernize and streamline your development processes. So with that, I'll now turn it over to Dan to give us a quick demo.
Great, so I'm back. Thanks, Mike, for the description of Zowe. And for all the parts of Zowe, the two pieces that we'll make use of on this next piece is, of course, APIs on the mainframe to facilitate uploading and downloading files to ZOS datasets, and also viewing my job output. And of course, the APIs are going to be consumed by Zowe CLI. So we'll look at shorter demo of revisiting that Hello World LC program and see how that experience of how an experience of changing that program can be made better with some of the Zowe technology. Okay, for a second and final demo for me, we're going to look at Zowe CLI and then building this Hello World LC program. First, just to see Zowe CLI in action, I'm going to issue a command, ZoweX jobs list jobs. And without trying to make sense of all this data, one thing that you should hopefully recognize is this 7 here. So the ZoweX jobs list command is displaying the information you saw on that green and black screen where I can see that my program returned a 7 and I can see the output here. Now I'm going to not go into all the details of all the different Zowe CLI commands, but you can do job information, upload and download files. But the real power, I think, in Zowe CLI is wrapping up Zowe CLI in some scripts and automation. So here I'm using a little JavaScript script for Node.js to run Zowe CLI commands. And this is just an example. I'm calling it run.js. And I actually won't use this sample as it's written here, but I wrapped up a bunch of consecutive Zowe commands to perform higher level operations. And then I'm working within the VS Code code editor. Right? Now with Zowe CLI, I can run that from any terminal. This VS Code editor has its own terminal, so I can run Zowe CLI commands in here. Then I can also begin integrating with the editor itself. So if you're familiar with VS Code, it has this ability to add your own custom tasks. I wrapped up Zowe commands behind my own scripts that are prefixed, that are encapsulated into the zdef command. So I have a zdef upload, which issues a bunch of Zowe upload commands, or I have a zdef make, which is going to run off and invoke my build job. Or then I have a zdef run to actually run my program. And then, because there's lots of cool extensions and ways to extend Microsoft VS Code, I can give these labels to my various tasks in here, like run, or build, and I can also put emojis in there. I use this other extension, a public extension, to take my tasks and add them to this status bar down here on VS Code. The point of that is now when I go back to my Hello World LC program, which I kept the 8-character name, Hello World, now I can edit my C code just in the editor. I immediately get some IntelliSense where I can mouse over symbols and learn more information, or I can control-click and navigate to see, well, this is what the WTO buffer structure actually is. And I can see what's going on behind the scenes here. And so then if I want to make an update to my Hello World program, rather than the green screen and all the steps I have to take and editing information, I can make a change here. Maybe call this Hello World faster, save that, and I can click this run button. Behind the scenes, my tasks are executing to upload the changes I made, whichever source files changed, invoke the build job, and actually run my program and direct the output right back to my terminal window. So before, when I had to view the job output and sysview, now I can see my output right here in the terminal. So I've worked solely in this environment and maybe can be ignorant of all of the green screen operations and things I had to do behind the scenes before. Again, there's a lot going on behind the scenes. With that base level of a command line calling back to a REST API and the mainframe and exposing mainframe services to APIs and easy CLI wrappers in front of that, I can wrap that up in my script automation, improve my developer experience, and I can make a code change much faster than I could before. And then I could also begin to wrap this up in some test cases, assert that the output is as I expected, and build out my pipelines and CI/CD. If you have questions, please hang around for the live Q&A. We can try to talk through any of the details here if you'd like.